Actually, I wasn't. Can I have that sheet?
One sec. Kaya's asking me for answers.
Don't give them to her. Kai's a cheater.
That's true.
Tell her to look on Ed's and she'll hear.
No, she's talking about AP.
Oh, thank you.
Hey, can you send me a picture of the third page of AP?
So, yesterday we talked about Pythagorean theorem. Again, you should know a lot about Pythagorean theorem. The part that was new to us is the converse of Pythagorean theorem. So if you don't know what type of triangle it is, you're able to identify the type of triangle based on the sides by plugging it into Pythagorean theorem. So we have, if c squared is equal to a squared plus b squared, it's a right triangle. If the c squared value is less than, it's acute, and the c squared value is greater than, it's obtuse. Now, there's one other part to this. Not all values have to form triangles. So if you're given 3 different lengths of 3 different segments, they don't necessarily form a triangle. So that's where this next theorem comes in. This next theorem is called the triangle inequality theorem.
Hey, what do we do with the paper we did?
Hold on to the paper from Bellwork because we're going to do more Bellwork tomorrow, and I'm going to collect it Friday for a grade.
Bellwork, you just have to copy it down once you show it.
Well,
Yeah, they don't get the answers.
so now, the triangle inequality theorem says to create a triangle, the sum of the lengths of any 2 sides must be greater than the third side. All right, so again, to create a triangle.
Has theorem always been spelled with 2 E's?
Yes.
I've always spelled it without the second E.
The sum
Here.
of the lengths of any 2 sides must be greater than the third side.
I can show you the work I did in 6th year. I went to English and I did the stuff in my PhD. Do you want to see it? Kaya's in, you can't ask her. I'll ask her right now. Did I go to English? It will be like this.
So we're going to do an example with this and how this applies to this.
Why is your handwriting changing?
Because you guys can't read cursive.
It's not in cursive.
Yeah, that's why he's not writing in cursive. Because he can't read.
Oh, so you write good in cursive.
Yeah.
Shut up, Brian.
Okay.
We should just listen to Signal Mode and call it back.
Hey, I got you.
Signal Mode or no bombs? Yeah, no mode.
Might want to finish after like that.
Yes, we have to.
Sicko. It's like, I gotta write it easier.
Make sure it's by Travis Scott, not Jake, because no one knows Jake.
Well, I have a couple of girls.
Yeah, that's it.
No, Bob.
Sun is down.
So we got 5 examples here. 3,
5 examples?
3, 5,
Jeez, dude.
Do we have
4,
to work that out? Or you
4, 9. No, I'm going to do these with you.
ha ha ha.
3, 4, 5, 6, 7, 13, and 5, 9, 10.
He's like, you realize you doing Jaden. He's gonna fail now. Who's he gonna speed off with?
Is that 449 from the second one?
Yeah, 4, 4, 9.
Wait. Actually, I'm adjusted.
I got lots of people in that class.
Oh, you have Ninja in that class. You put him like that.
All right. Anyway, 3, 3, 5. All right. So what we're looking for here is to see is this going to make a triangle first off? So if I take 3 plus 3 That adds up to 6. 6 is greater than 5. So that should work for a triangle. Now, really, the way this is stated, you should be able to check any two sides and see it's greater than a third.
Yeah.
But you really only have to do the two smallest. So if I was to add any of them together with the biggest, of course it's going to be greater than one of the smaller sides, right? Because 5 by itself is already bigger than the other two. So you don't really have to look at those other pieces. Now, so this one works as far as a triangle goes. All right, let's go to the next one. 4, 4, 9.
Can you explain?
Yeah, so 4, 4, 9. Ready? We have 4 plus 4 is 8. Is 8 greater than 9?
No. Yes.
Is 8 greater than 9?
No.
No. So that's not a triangle.
So if you add them up and they don't equal...
They have to be greater than the third side.
Okay,
So
what is
take the two smallest. This is just to see if these parts can give us a triangle.
Okay, so...
All right, because
we don't even have to look at 4, 4, 9.
don't even have to look at 4, 4, 9.
Oh, okay.
So then 3, 4, 5.
Yes.
3 plus 4 is 7. 7 is greater than 5. That's a triangle.
And he's lying.
I just made a 4, 4, 9.
6, 7, that equals 13. It's not greater than 13, so that's not a triangle.
Oh man, I'll make a triangle right now.
5, 9, and 10,
Yes.
Yes.
those two add up to 14. That's greater than 10, so that's a triangle. So, to show you why these other two don't form triangles, if I was to have, let's say, a side length that was 9, and then I had another side that was 4. Now, obviously, these are not intersecting the way I have them. But if I tilted them in,
No, that's a triangle round.
if I was to tilt these in, they would never intersect, right? Because even if I drew them in a straight line with this, I'd still have, this is only 4, that's only 4. Together there's a gap of 1. So they will never intersect with one another. Even if you have two values that are equal to the third, so let's say I had, the longest side was 13. One side was 6. And one side was 7. Well then, if I was to tilt them in so that you try to make them connect, they will intersect, but only on the line. So you wouldn't actually have a triangle, you just have those two other segments would be on the same line, so you'd only have one line. You wouldn't actually have a triangle. So in order for a triangle, or in order for three sides to make a triangle, any two sides have to be greater than the third. So if you check the smallest two should be greater than the third side. So that's how we're able to say these two don't work, but these other three do. Now that we know that those three are triangles, we can use Pythagorean theorem to identify whether it's right, acute, or obtuse. So on the first one, if we were to plug this in, again, the longest side will always go in for our C value. So 5 squared equals 3 squared plus 3 squared. 5 squared is 25. 3 squared is 9. This other one is also 9. So 9 plus 9 is 18. The 25 is greater than 18. Therefore, this is an obtuse triangle. On the 3, 4, 5. All right. Again, 5 is the longest side, so that would be our C value. Plug in the 3 and 4 for A and B. 5 squared is 25. 3 squared is 9. 4 squared is 16. Add 9 and 16 together and you get 25. They're equal. Therefore, this is a right triangle.
And then if A plus B equals more than C, it's acute.
Yeah. Well, I would always talk about it in terms of your C value because it makes sense when you think about what a right angle, acute angle, and obtuse angle are. Obtuse is an angle that's greater than a right angle, right? So if you have, again, talk about it in terms of your C value. If C squared is greater than, it's obtuse. An acute angle is smaller than a right angle. So if C squared is less than, it's acute. That's one of the reasons why we write the C value first. Yeah, I'll stay right there. So then, to finish this one off, 10 squared equals 5 squared plus 9 squared. 10 squared is 100. 5 squared is 25. 9 squared is 81. 25 and 81 together would be 106. So 100 is less than 106. Therefore, whoops, this is acute. So we have an obtuse triangle, a right triangle, and an acute triangle. Now, there is one other thing that we can do with this theorem, and that's identify a range of values that could be the third side of a triangle if we knew the lengths of two of the sides. So, this next part, we're going to say what range of values could the third side of a triangle be given two of the sides.
Well, I've already used up 2 sheets of paper. How much are we going to write?
Maybe you should just be simple.
Hey,
So we're going to have 4 examples here. We're going to have 5 and 7, 8 and 12, and 5 and 9. Yeah. So on here, again, if we think about this in terms of these two numbers, 5 and 7. Well, if we were to add 5 and 7 together, what do we get? 12. Now, could 12 be the third side?
yes.
Well, if you add 5 and 7 together, you get 12.
Yeah, no.
It's not greater than 12.
Be greater than 12.
So that for that third number, we can't have 12, but we could have anything that's what compared to 12.
24.
So you think more than 12? So let's try 13. 5 plus 7 is still 12. Is 12 greater than 13?
No.
No. So you went the wrong way.
Oh,
So
11.
we want less than 12. So when we talk about the range here of values,
Oh.
our third value is going to have to be less than 12. Now, how do you think we might find the bottom end of our range? So we added them to find the top end.
11.
No, it has to be less than 13. No.
So again, this is the top end of our range. We added them, found the top end of the range.
0.
How do you think we might find the bottom?
0.
0.
And it's not just going to be 0 every time.
1.
There's going to be something that we have to do with these two numbers.
7.
2.
If we added them to find the top, what do you think we might have to do to find?
Subtract. 2. 2.
2. All right. So
Is it going to be dumb?
Yes.
2. So you shouted out 2, but I needed a reason why you said 2. All right. So the difference is what we're looking for when we're finding the bottom end of the range. And to see that this works, if I did 2 plus 5, that's 7, right? Now, that's not greater than 7, so any number bigger than 2 would give us a number that's greater than 7. So our range of values here are going to fall between these two numbers, but they don't include these values. All right, so you might want to write a side note there. The range will be between the sum and difference. All right, so we're given two values. The range of the third side will be between the sum and difference. Range will be, you can write it underneath if you need to.
You don't even know what underneath right now. Where's underneath? It means
Underneath where? Underneath the what? Oh. Right in here. I wrote on the side, dummy. Right here.
So now, for these, all right, we got 8 and 12. So the bottom end would be 4. The top end would be 20. So we subtracted to get 4, added to get 20. For this next one, we have 5 and 9. So the bottom end of the range is 4. Top end is 14. Yeah, and that's it. Again, it does not include the numbers. It falls between those values. Now,
So it could be 5.
so 5 would work. And a lot of times for test questions, I'll probably give you a select all that applies for this type of question. So, like say the first one. if I gave you this, I'd probably ask which of the following values could work as the third side of the triangle. And then I'd probably list 2 and 12 would probably be options. But would those be answers?
No.
No, because again, it has to be between them. And then I'd probably list something in the middle or more than one number in the middle, maybe something outside of the range. So again, you have to know that it's the values that fall between the sum and difference. All right.
So the option has to be 2 and 12?
I'm saying that if I make a test, or if it's on some type of standardized test, or if it's on the FSA, and you have options for something like this, you will almost always see the 2 values that the top and bottom of your range listed. But remember, it's not going to be either of those. Those are never included. It's always between those numbers. All right. So one last thing for notes. The last thing we need to talk about is Pythagorean triples.
Oh, these are some stupid.
These are fun. Yo, stupid's a mean word.
You're stupid.
Stupid is a mean word.
I heard last period you were like, all right, that's enough Pythagorean theory. Can you do that with last period?
No, that's not how it works.
Did you actually
So
say
now,
that?
no.
Wait, you did?
Pythagorean triples. There are a couple different ways that you can define Pythagorean triple. I think the definition I like the best is Pythagorean triples are when all 3 sides of a right triangle are whole numbers.
What did they say?
Are whole numbers? I
Yep.
didn't say a right triangle, you just said a triangle.
No, I said right. So, key thing here, the fact that we're talking about a right triangle and whole numbers. Again, in order for it to be a Pythagorean triple, all 3 sides of a right triangle have to be whole numbers. Now, the other way that you can define it is 3 numbers that satisfy Pythagorean theorem that are whole numbers. That would mean the same thing, because if it satisfies Pythagorean theorem, it means it is a right triangle. Yes.
So, if the right triangle sides are 3, 3, and 3, they're all whole numbers, so would that make it Pythagorean triple?
No, it's not a right triangle.
No, because that's not a right triangle. If you were to plug that in to our Pythagorean theorem, you'd see that one of the sides, after you squared it, is less than the other 2 sides squared, so it'd be an acute triangle. So again, it has to be a right triangle. Now, there is one that we've done a couple times on here that is a Pythagorean triple. 3, 4, 5. All right. We also, on our bell work, did another one, the 5, 12, 13. This is a list of some of the Pythagorean triples. Now, you don't have to memorize every single one. All right. The most important ones are these first 2. Now, which ones would be good to memorize? I'd say the first 4, maybe even the first 5 would be good to memorize. Now, not only are these Pythagorean triples, but also any multiples of these. Because if you have similar triangles, going back to what we did before we went on break, similar triangles, you can take a scale factor and multiply by that scale factor every single side. And say we had a scale factor of 2. Well, multiply every single side by 2, I'd get 6, 8, and 10. Those are all whole numbers, and they would be a right triangle still. So that would also work. Any multiples of these also work. I will post
10, 24, and 26 would work?
say that 10, 24, 26 would work, yes. So any multiples of any of these values would also work. Again, these 2 are probably the most important. I'd say you should know the first 4, maybe even the first 5. All right. I'll post some of the Pythagorean triples to Edsby, so that I'm not going to write all these down right now, but yeah, they'll be up there on Edsby. But again, there are a lot of Pythagorean triples. All right. Here's another sheet of lots of Pythagorean triples. But again, would I ever have you memorize something that goes out to be that big of numbers?
Probably.
No. So again, the further out you go with numbers, the more Pythagorean triples there are. We're going to keep it pretty basic. Now, the thing that you have to remember, let me put this sheet back up. You won't always just be asked a question, is this a Pythagorean triple? Now, on your next test, next quiz, you might be asked something like that. Which ones are Pythagorean triples? And it could be a select all that applies. However, for like the rest of this year, you will probably see a Pythagorean triple on almost every test from this point out, because same thing goes for the FSA. You'll see Pythagorean triples mixed into other problems. A lot of times, you'll be asked a question that, if you know the Pythagorean triple, you don't have to do any work. So, say you're given a triangle and you're asked to solve for something else that required something that we're going to do later in the year. Say you're doing like a volume question. In order to do the volume question, you had to know the missing side of a figure. Well, if you know the triples, you might be able to find that missing side and then be able to plug into volume. If you don't know the triples, then you'd have to go through Pythagorean theorem and spend more time on the question. So again, if you know your triples, it's going to help you save a lot of time as the year goes on. Yes?
What's the last number of the book?
It's 17.
Oh, on that one, 17. Yeah.
Whoa, how do you know that, Brian?
Because I know my Pythagorean triples.
Really?
Zach, shut up.
I can't believe that. Like,
All right. So that's it for our notes. The homework tonight is on the board there. It's page 289
All right, 10 minutes. Let's do it.
to 290, 1 through 15. Now, we have 10 minutes left in class, since I only have the 5 of you in class. If you want to work on the assignment, that's fine. Do you want me to go over any other examples? No? All right.
Yay!
can you put the bell work back up there?